This tutorial shows how to conduct the one-sample t-test in SPSS and interpret its results. The purpose is testing the mean of a variable, also called sample mean, against a population mean, or simply a test value. For instance, I have a sample and want to see whether the average height in centimeters is 175. Of course, you can formulate one-sided hypotheses as well. Requirements for the one-sample t-test are the following: a test variable on an interval or ratio scale, and an approximate normal distribution of your test variable. Testing for normal distribution is shown in a separate video linked in the info cards to keep this video more concise. You can conduct a one-sample t-test through Analyze, Means and Proportions, and select the one-sample t-test. Take your test variable and drag it to the right to the test variables box. The important part is to specify a test value or population mean, which you obviously had to define in advance. In my example, I'm testing whether the mean of the height is different from 175 centimeters. The options merely allow you to specify a confidence interval, which is set to 95% by default. Handling missing values can also be left at the default option of case-by-case exclusion. This of course only applies if you have more than one test variable at the same time. Use the bootstrap option if you run into trouble with the normality assumption. This will generate additional output. Please also make sure that the estimate effect sizes box is checked, which is a feature since SPSS 27. The results will eventually be shown in the output viewer. You will by default get basic descriptive statistics for your test variable, consisting of the number of observations, the mean, the standard deviation, and the standard error of the mean. This will show you whether the sample mean is potentially different from the test value or population mean. Now for the t-test itself. Depending on whether I test one-sided or two-sided, a different p-value should be looked at. Reminder, one-sided testing is applicable when you are hypothesizing either a higher or a lower mean than the test value. For my example, I'm simply checking whether my average height is different from 175 centimeters, making it a two-sided hypothesis. Therefore, looking at the two-sided p-value is appropriate. If the p-value is below the predefined threshold, for example 0.05, the null hypothesis can be rejected. Reminder, the null hypothesis assumes no difference between the sample mean and the population mean or test value. The alternative hypothesis of the one-sample t-test is what you are actually proposing, one or two-sided results. In my case, I defined alpha as 0.05 and can therefore not reject the null hypothesis based on two-sided testing, because my p-value is 0.07 and above my predefined threshold. I can conclude that my sample mean and population mean are not significantly different. After a significant one-sample t-test, the effect size should also be looked at. Even though my t-test was not significant, I'm pretending it is to show you how to interpret the effect size. The effect sizes are shown in the third table. You're looking at the point estimate column for either Cohen's d or Hedges' correction of d. Hedges' correction of d will be a bit more conservative or biased, depending on the stance you'll take. For the purpose of transparency, I would advise reporting Cohen's d and Hedges' correction of d, despite the differences being small. Finally, you have to classify the magnitude of the effect. Always report absolute effect sizes and classify them. If similar studies in your research field exist, compare your effect size with the given one. If no comparable study exists, use the common thresholds within your research field. If those are also non-existent, you can refer to Cohen 92, a power primer. Page 157 shows 3 thresholds for the one-sample t-test: 0.2, 0.5 and 0.8 for small, medium and large effect sizes. In my example, the Hedges correction of Cohen's d is 0.255 and could be classified as a small effect if it were significant. When you're done, you have to write up the results. The video that appears now will show you how.